Good morning, ladies and gentlemen. It's your favorite math teacher coming to you live from a pineapple under the sea. It's SpongeBob SquarePants. Psych. It's me, guys. I don't live in a pineapple under the sea. How can you even have a computer under the sea? That doesn't make sense. We can't be doing that. It doesn't make sense. We can't be successful if we believe we're going to be taught by a sponge. I don't think they have brains, actually. And that will have something we'll have to verify. All right, anyway, so you watched the last video on Pythagorean identities. Now we're going to practice the purpose of identities. Remember, the goal of identities is to get two sides of a trigonometric equation to match up. We're going to start with the simple one. The first one we're going to look at, pretty straightforward, is cosine of theta times cosecant of theta times tangent of theta equals 1. So we got that. Easy enough, right? So that being said, you'll notice this is a product. We don't have any degree higher than 2. It's just a string of trigonometric equations. The way I would recommend doing this is, first, again, since we see it's a product, let's rewrite everything in terms of sine and cosine. You'll see that for a lot of these, sorry, I'm going to switch to just visualizer. You'll see for a lot of these, it's really helpful if we can get everything into common terms. Our goal is to really simplify this. Look, we're trying to get this to be 1. So we have cosine of theta. Now, if we look at our formula sheet, or not our formula sheet, our identity sheet, if you do not have that, please get that out now. Cosecant is 1 over sine of theta. Make sure you see that on the sheet. And then tangent of theta is sine of theta over cosine of theta. Now, the nice thing is, we do these substitutions so we can further simplify. Because I wrote out cosecant in terms of sine, I can see that these sines cancel out. Because I wrote tangent in terms of sine and cosine, I can see that my cosines cancel out. This leaves me with 1 equals 1. Again, our goal is to get these two sides to match up. We're really lucky they picked a topic that all of the trig and pre-calc classes have covered already. I know this is a kind of tricky one, but if we kind of focus our attention as to the substitutions we need to focus on, you're going to be successful. This does take a little bit of practice, but they don't give you that many problems to do. So that's why we're going to go over a few of them. Now, the next one. You'll be able to see it's a little different right away. 1 minus sine squared theta over sine squared theta equals cotangent squared theta. Now you guys are probably thinking to yourselves, looks complicated, really not that bad. There is some substantial differences between the previous two, or the previous example. I'm going to pull up this one so you can see it. Notice in this example, just a product, right? Cosine, cosecant, tangent. Here we have a lot more going on. We have a difference and a division bar. Now, kind of your bigger clue is this right here, right? When we see these squareds, we want to be thinking Pythagorean identities. Like that sheet we created last class is going to be really helpful. In fact, when you see these squares, especially when you see a group with a minus or plus 1, we want to be thinking, well, maybe there's a Pythagorean identity that can help us there. So we're going to go check our sheet. I'm pulling out my sheet that we wrote last time. I'm looking for 1 minus sine squared, which I see is equal to cosine squared theta. So I have cosine squared theta divided by sine squared theta equals cotangent squared theta. We're getting very close. We did a substitution. Now, the substitution made this expression easier to work with. We went from a binomial to a monomial. Very, very helpful here. We normally do substitutions so we can have, again, a more simple expression. Here, we go back to our formula sheets. We constantly want to be looking at the formula sheet. This isn't just like algebra. There's a lot of trig involved here, so we need to make sure we know those identities. Cosine over sine is, well, cotangent of theta. And this is true even if they're both squared. In fact, they both have to be squared for this to work. Or, I shouldn't say squared, but to be the same power. Cosine over sine, cotangent. Cosine squared over sine squared is cotangent squared, which is exactly what we want to see. Easy enough, right? We're trying to get these two sides to match up as best as possible. We're going to look at another one. Actually, we're going to look at two more before we wrap this up. Now, again, I'm really going through these. I'm not trying to go through it quickly. You guys know you can pause the video at any time, go back, rewatch. And if you don't really understand my process, shoot me or your teacher a text, or we can talk about, or a message in Schoology, or you can talk about it in your meets. The next one, we're going to keep increasing level of difficulty here. The next one we're going to look at is 1 minus tangent squared theta over cotangent squared theta squared x. Sorry, we're going to use theta minus 1 equals tangent squared of theta. Actually, guys, we are going to scrap that example. Looking at the paper copy, and this isn't something that they really cover too much on that, so I don't really want to get too far away from the paper version, so you can cross that out. Remember, nobody's perfect. Happy little mistakes. The example we're going to look at next is sine of theta times the quantity 1 plus cotangent squared theta equals 1. And what I would like you guys to do, pause the video and see if you can try this one on your own. Alright, so clues here. Sine, we already have. Sorry, this should be sine squared theta. Sine squared theta. My apologies if you paused it and it didn't work out. We have an expression. I'm going to leave it there. I don't want to, very rarely do I exchange a single monomial and want to get a binomial. Make it into two things. Really, that is not helpful most of the time. This, on the other hand, right, we see a quantity 1 plus cosine squared theta, right? I think we can rewrite that out. If we look at our sheet, 1 plus cotangent squared theta is cosecant squared theta. So we have sine squared theta times cosecant squared theta. Again, we turned two terms into one. Now, we have a product. Remember, when we have a product, it's helpful to rewrite things in terms of sine and cosine, kind of putting the first example and the second example together. We know that cosecant is the reciprocal of sine. So we have sine squared in the numerator and sine squared in the denominator. They both cancel out. We're left with 1 equals 1. Pretty simple example there. Again, it's kind of putting these ideas together. A lot of times we substitute so we can simplify to substitute again, or we substitute so we can substitute so we can simplify. It's really rearranging all of the pieces so that way, well, we have something much easier to work with. All right, and we're going to look at one more today. The last one we are going to look at, probably the most complicated, but that's how math class is, right? We increase in level of difficulty. We have tangent cubed x plus tangent of x. We can put both these. The parentheses really aren't necessary. Every once in a while I'll put them in there, just so you can see a variety. Divided by secant of x is equal to secant x tan x. All right, so you'll notice something a little different here to the third power, right? We don't really know any identities with tangent to the third power. Sometimes what we're going to have to do before we actually complete a substitution is actually do some algebra here. We actually have a GCF. If you think about this as t cubed plus t, right? You can see the relationship between those two. That can be rewritten out as, we can take out the t times t squared plus 1, right? That's GCF factoring, kind of like reverse distribution. I took out a t from both of those expressions, or a tangent from both of those expressions. Like so, right? GCF factoring, doing a little bit of algebra, can make this pretty simple. We're going to have to do algebra in some of these problems, right? Now, we're looking at our examples here. Look what we have. Boom. Now we have something squared, let alone squared plus 1 or minus 1. This is a clue. We need to check our formula sheet or our identity sheet. We need to be constantly looking at that. Tangent squared x plus 1 is equal to secant squared. So we have tangent of x times secant squared of x all over secant x. Right? And we need to keep in mind what we're trying to get to. We are very close, as you can see, right? Now, again, we've done some algebra to do some trigonometry, a substitution. So hopefully we can simplify. We have secant in the denominator and a secant in the numerator. This is kind of like s squared over s. Again, a very analogous algebra relationship. Cancel out. We're left with just s. This leaves us tangent of x, secant of x equals secant x tan x. Now I will let you know they should look identical, so I am going to rewrite it as secant x tan x equals secant x tan x. Some teachers are sticklers about it. It really is important that they do match up exactly. Make sure that's the case. So I hope you guys found this video helpful. I'm going to switch it back so you can see me. I hope you guys found this video helpful. I know there was a little mistake or extra problem I did in there. Don't stress about that. If you want to try it, it's kind of difficult or fun. Weird way of putting it. Fun is very relative. Well, I'm going to get back to painting a wall, and hopefully I'll see you guys next week. If you're in my classes, I hope to see you in the meet. I hope you guys are having a great time. Stay safe. Make sure you guys are getting your exercise, eating healthy, you know, the works and stuff. All right. I miss you guys. Have a great rest of the day.